Hello, everybody. Welcome back to episode 2. So if you remember from episode 1, hopefully you attempted the cube function. If not, you're picking up on episode 2. That's completely fine. We're just going to walk right through it right now. So let's start off right up with our parenthesis and what comes right after our parenthesis. If you remember from episode 1, you're right. Our procedure call. Well, I'm hoping you're right. Um, so we have our defined keyword. And let's just call this cube, right? Because we're just cubing a function. Again, we have our parenthesis followed by a procedure call, which is generally going to be lambda. And again, you're kind of seeing this pattern of the define and then immediately the lambda. So what do we want to do? How many variables do we want to pass into this function? Well, remember a cube is essentially, we want to be calling cube on a value. So let's use 5 as an example. We're basically saying we want to have 5 times 5 times 5, right? So we want to take one value. So we'll pass it in as x. From here, we simply just want to evaluate. So we have our parenthesis and we need our procedure call. So what do we want to do here? We want to do our multiplication, right? So remembering that the procedure goes first, we have our multiplication sign. And here we have to think, right? Because our multiplication sign, if we remember from the first episode, takes two values, our 4 and 2, or 2 and 4 in this case. So we can't do, in our case, 5, 5, 5, because that would be one too many parameters. So how do we get around this? The way we can get around this is simply saying x for our first variable, and we can do another procedure call where we have our multiplication, where we have x and x. So what this is essentially doing, if we close this parenthesis here, is saying, hey, let's take x multiplied by x as this parameter and multiply it to this parameter. So we're saying, hey, we want to multiply this with whatever the product of this is. From here, we see that we closed this line off. We want to close off our lambda, and then we want to close off our cube. And if I hit run here, hopefully we have no errors. So perfect. And before I want to go further, I just want to kind of, give a little heads up. Remember when you're doing your command line stuff to always remember this parenthesis, because if you don't and you do cube 5, well, we can see that that's not going to quite work. We have our procedure come up, which is correct. We are calling our procedure cube, and then the number 5. So that's not correct. We want it to actually evaluate something. So we're just going to go cube 5. So now that we're done with the cube function and the work we did for our previous chapter and the previous video, we can kind of move on to the main topic of this video, and that's going to be the concept of lists. Now, lists in Scheme are made up of smaller elements called pairs, and pairs are just quite simply two elements put together, or three elements, but the first element has to be something that you can perform a car procedure on, and the second element is something that you have to be able to perform a CDR on. And what I mean by that is car and CDR are two functions, are two procedure calls within Scheme, and we'll get into them in quite a minute, but first I want to finish up talking about pairs. So if we look at the bottom here, we can actually use a built-in procedure called pair, and what we're doing here is we're passing values in, and we're going to get a true or false depending on whether or not the parameter is actually a pair. And you can kind of think about this as the same thing as above. So imagine we're just defining something called pair, and we give it a lambda of LST. So we're basically passing this list into a predefined and pre-created for us function or parameter called pair. So we're passing AB into a pre-made parameter called pair, and this is returning simply true or false whether or not this parameter that we're providing is a pair. And we can kind of see what happens if we provide it an empty list, which we get false. So remember that concept of it has to be a pair if you can char or CDR it? Well, let's get into that right now. So what does char do? So char is a procedure, so we have to have our parenthesis and then char, and we have to pass in a value to it. So let's pass in our list of A and B. So what char does is it takes a look at this list and returns the lead element in it. So we can see that in this case, it's A. If we look at CDR, it does the exact opposite and returns every element but the first, which means we get B as a result. And we can kind of see this in better examples if we use longer lists. So let's take a look at a char of a larger list. Let's go with A, B, C, and D. So in this case, what do you think the char should be? Hopefully you said A, and we can take a look and see that indeed it is A. So if we look at the CDR of this list, if you can take a guess, B, C, D. So it gets everything except for A. And you can kind of see the building blocks of how we can iterate through lists within Scheme. Because if we see that we now have a resulting list of B, C, D, so let's put it right over here, our list B, C, D, what would the char of this list be? Well, we could see that that is B. And from there, we can do again the CDR of this very same list, CD. So you can kind of see that we're literally doing the building blocks of stepping through lists element by element. We can keep doing this. We keep doing the char of, CD and get that as C, and then the CDR would be D, and we can keep doing that. But that's how you step one by one through lists, and we'll kind of build into this when we look at the topic of recursion. But for now, I just kind of wanted to get the concept into your heads so you kind of know where to go from here. So how do we make lists? Well, we can do the basis of what we're doing before, what we had before, which is literally just, A, B, C. But we can't really manually do that within code, right? In code, we have to find a way to generate lists. And the way we can do that is using a built-in procedure that's provided for us. And this one's called cons. So we can take a look at cons. So we need to provide elements for cons. In this case, cons takes any two S expressions, and S expressions are basically just anything. Within Scheme, they're kind of a base element. You can do a quick Google for S expressions. It'll give you a ton of really good examples. But for this, we're just going to use two lists. We have a list consisting of just the A, and then we have a list that has nothing in it. If we cons this together, we can see that we get A in a list. So perfect, we've created a list. If we do another cons, and we have A again, but let's try an element, or let's try a list with multiple values in. We can see that we have A, B, C. So it combined these things. So you can kind of see that cons is a way to combine lists or combine elements into a resulting list. So let's keep building on these kind of useful functions that we're using. And I want to work through some functions that'll help you kind of identify what you're working with in your logic for when we start building out our bigger functions as examples. So let's take a look at null. So in this case, what we're doing is we're basically saying, hey, is the element that's being passed in null value or not? And what we mean by that is we can see that in this case, we're just giving an empty list to null. In this case, it returns true because there's no elements within the list. If we do a list example of A, B, C, D, we can see that null now returns false because there's an item in it. The next thing that we can go on to is simply list. So again, much like null, we're just comparing to see if this is a list item. In this case, because an empty list is still a list, we get true returned. If we do something like, let's try the number 1 in list, we see that this is false because we're passing in a number rather than a list. So we can see that in action. Another useful function could be the length. So the way we can do this is simply just calling length and passing in a list as our value. So let's just do a list A, B, C, D, and we can see this returns 4. And let's go ahead as an example and create a function that basically does this for us, but we need to build it out because we want to, get used to creating some functions in Scheme. So let's define length finder, and we'll call it length finder. And again, lambda, we'll call it list, just so our variable names are a little bit better. And we're just going to be doing the length of the list. So if we run this, there are no errors. So let's try this. Let's do the length finder, and let's pass it in A, B, C, D, and you can see we return 4. Now, of course, we could have just done the original length like we did before, but I think this is a good example to help you kind of build on, just creating and defining functions within Scheme. There's one more thing that I want to talk about before we wrap up with lists in this episode, and that's the concept of concatenating car and Cadr. And what I mean by that is if we do the car of the CDR, so let's try that. Let's try car, and then we pass it in the CDR of our list. And let's logic through what's happening here. So we have A, B, C, and D, and if we remember, the CDR of our list A, B, C, and D is in itself another list, which just contains B, C, D. So our car function returns B, C, D, and we immediately pass that into, our CDR procedure returns DCB, and we pass that into our car procedure. So we can think of it like this. So we now have car of our resulting B, C, D, which would give us, hopefully, B. So let's try that. And again, we have B. So we can do that. We can keep doing that. We can do the car of the CDR of the CDR of A, B, C, D, and we get C. But there's probably a better way to do this, and thankfully there is. And we can kind of see that using our concatenation. And what I mean by that is this. So we're saying the car of the CDR. So you can see how there's the CA and the CDR. So we're taking the car of the CDR. So CDR, just add an A. So let's try that and let's see what happens. CDR, just add an A. And let's try our list, A, B, C, D. So we have B. So this is essentially adding the CDR and then the car of that. Let's do it again. And the way we can keep building on this is adding D to it. So 2 Ds, so a CDR, and then our car. So that is equivalent to this line right here. And let's try that. And we have C. So let's try it one more time. You guessed it, to go one further in the index, we just add another D. And then let's provide it the same values, and we have D. So that's just one more thing to help you kind of keep traversing through lists. And in the next episode, we're going to kind of go into pretty simple recursion to kind of start building on this concept of lists, and we're going to do some really cool things with lists and basic recursion. So thank you so much for watching. Hopefully video 2 was good. If not, throw me in the comments on how I can kind of make Scheme make more sense for you. So thank you.